Hello, and welcome back to our Wordle project adventures. Today we're going to create a Wordle guess predictor where we will have an input file with the Wordle target word, which is like the correct answer, and it will return to us the guesses that our program will make and the number of guesses it will take to solve this problem. And the purpose of this program is to find out if our program can guarantee that all words can be guessed within 6, or if there are words that will require more than 6 guesses. So we have our original Wordle program code here, and I'm going to make a new file. We're gonna call it Wordle Predictor, and so this is obviously our Wordle guess predictor, and basically what it's going to do is predict the guesses and number of guesses for a given 5-letter Wordle puzzle. Okay, and let's see. So I want to design this program to cover as many words as possible. So I'm not going to set it up with command line, but we'll have our command line just for debugging for now. We can remove it later. Obviously we're going to need our file stream. We're going to need our string class. We're going to need our vectors. And we have our original set of words, and we have our counts. Oops. Okay. This is our basic setup for our program. Okay. So since we might have input files that contain multiple words that we want to predict, I want to only have to read in the words once instead of reading the file over and over again every single time we test a new word. So that means I'm going to have to have a vector. So the vector of the words is going to store everything I read in from our word bank, and then the vector of strings that we actually use, like we did in the previous Wordle program, the vector of strings that we use and modify to make guesses and reduce our word bank size should be a separate vector. So we're just going to make a separate vector. Words. Okay. And yeah, that should be fine for now. Counts, we'll just run it every single time. Yeah, and then yeah, okay. So then let's start our program. Obviously the start of our program is going to be basically the same as the previous Wordle program. So obviously we're gonna initialize our counts with a init counts program. So we're gonna have void init counts, and then we're gonna want to get it from here. You can just copy it over. There's no difference there. We're just setting all the counts to 0. Then we're gonna want to read in our word bank. Okay. Read in our word bank. Okay. I think it should be the same. Just do the same thing as we did before. Do we need to calculate statistics for the beginning? Maybe. We'll just leave it for now. Same thing. Get our stat word calculator. Okay. And then after that's done, we can just close it. Okay. Then we're gonna want to open our target file stream. So this is gonna be the file with all the words we want to test and find out how many guesses they take. So we're gonna call it input.txt file, and it's just gonna contain all our guesses. Okay. Let's see. We're gonna want to output information regarding the guesses that were made for each of these words. So we're gonna also need to open a output file stream. Out. Oh. Okay. Okay. And obviously we want to close it later. Make sure we don't forget our return statement for our main. Okay, so then in here, we're going to want to iterate through all the words inside our input file stream, which contains all our guesses, all our target words. So. And yeah, okay, so we're going to want to format the output as the input word, and then it's going to be guess 1, guess 2, guess 3, etc. And then it's going to be the number for number of guesses. That's going to be each line in our output. So obviously this is going to begin with our initial output. So like that. So that'll cover the first section right here. We want to know what our guesses are. So okay. So, and we also want to track the number of guesses. So we'll have our initial guess counter to be this guess attempt. I'll index it at 0 for now. We might need to change it later. Hopefully not. And then, let's see. Like that. Okay. So, for each guess, right, we're going to want to have, there's going to be a loop that's just going to keep guessing. So we're going to have a string that has the guess, and then this loop, let's see, we're going to keep looping while active words vector is greater than 1. So instead of these 5 guess attempts, we want to keep guessing until it's out. And so it's basically the equivalent of doing a while loop here, and then if it becomes 1, it'll break out. And we'll also allow the possibility for it to become 0, because who knows, maybe we just can't find this word, you know? So we're going to keep guessing until this, and let's see, inside we're going to have a guess. So we're going to make a suggestion. So this is some function that's going to return us the guess based off of our current active words. And then once we get the guess, we're gonna output that out to the string, so we're gonna have our guess, and then actually I can remove this space and I can put the space in front. See the space in front. Okay, and then we want to evaluate this guess by taking the guess, comparing it to the target word, and then this function should change the size of active words and reduce the active words to the remaining possible answers. Then obviously we have to increase our steps. So it's gonna look something like this, I think. Yeah. Let's see, is there anything else that might happen? Well, okay, so after this finishes, we're gonna want to check if it's the correct solution. Actually, check if no solution occurs. No solution would occur if active words is empty, because in theory, if we find the actual word the target word will always remain in active words. It will never get removed. So if active words becomes empty, then something definitely went wrong. So we'll just put like this error. Yeah, we'll just throw in an error. And this will just continue to the next word in the input file. Okay, so that's no solution. Check if correct. Check if it's the correct solution. Output solution. Okay. So if the guess is the input, then let's see. Active words size is greater than 1. Oh well, this could actually terminate prematurely, huh? Okay. So what happens if active words out size is large and our guess is the correct answer? Then we go through, evaluate, input, and then all that's going to be left is one word, I think. Is that correct? Yeah, so it should only leave one word. So if we find the correct word, we'll go through, guess the tempo increase, and it should be the correct word. And then we can just output, so if guess is equal to input, then we can just output that it's the correct, the guess attempts. Yep. Right, so we come out of this loop. If we come out of this loop, that means there's only one word left. There's only one word left. Oh, there's only one word left, or the guess is the input. Right? Well, no, because one word left. If the guess becomes the input, then it'll clear, and then it will do this again. It'll go through this again, and then it'll, because there's active word size will be 1, I think. Try again. Well, okay, I think I can just leave it for now. This should be fine. Okay. This. Okay. Oh, okay. We need to reset the active words before we do each set of guessing for each input. Otherwise, it's just going to be the reduced version from the previous guess, and then that would be a disaster. So we need to do a reset. Afterwards, gets cleared, and then we can just go through. It's probably a better way to do this, but we can just quickly just loop through the words, and we just reinitialize active words. Okay. Save that for now. Okay, So what functions do we need? We need our make suggestion function, and it's going to return a string. And then we are going to need, let's see, make suggestion function. Oh, and then we're going to need an evaluate guess function, which doesn't return anything. Oops. But it takes in our guess, and it's going to take in the target value, and we're going to evaluate. Okay, so that's that. So let's write the make suggestion first. Okay, so make suggestion. This is supposed to return the correct suggestion to whatever the word is. So this is like our previous Wordle program, just like this make suggestion. So we're gonna want to clear the accounts. We're gonna want to retake statistics. We're gonna want to do it for active words. So let's make sure we change this to active words. Oops. And then let's see. And then we're gonna want to return. Instead of printing it out, we're gonna want to just return the find strongest word. Right. Okay. So obviously we need this find strongest word function, which can be found here also somewhere. Let's see. Here it is. Okay, so we're gonna copy this. We get this. So this is gonna be root strings. Okay, so we don't care about the outputs anymore. So we can get rid of that. Strongest word, the words. Let's see. We want to change all of these to active words, so active words. Like this. Oh, no output. Calculate strength, blah blah blah. Return strongest word. Should be fine. It's basically the same thing as what we did in the previous Wordle program. We're gonna need this word strength function, so that's right here. Boom, bada boom, bada bing. Here it is. This is going to have to be active words. Actually, wait, no. This is the word. Yeah, okay, so it's just the word. So this doesn't need to be changed. Counts, it still counts. Okay, so that's, these three functions together should return the next best guess. Okay. So back up here, we're going to have our guess back, and then let's see. Get our guess back. And okay, so we need to write evaluate guess now. Okay. Come down here. We want a function evaluate guess. String the guess. String the word. Sorry, not the target. I think this is what I called it. Yep. String the guess and the target. So here we are. And it should be similar to our guess feedback. But we need to evaluate first so that we can get these character, the value, like 0, 1, or 2, and also the index. So we need to go through this word first. Okay, so obviously we're gonna want to iterate through the 5. Let's see. Yes, the 5. Oh, I just installed a extension for VS Code called Prettier, and it adds spaces to things, and like it just does better formatting automatically. Not quite used to it yet, so I keep thinking that I need to type it myself, but it just does it for me. So Okay, so we're going to iterate through the 5 letters. We're going to assume these are 5-letter words, nothing fancy. And we're going to iterate through the letters in the guess, and we're going to want to match them to the target. So obviously it's going to be a 2. It's going to be a 2 where position and character, position matches and the character matches. Right? So this is a 2. So a 2. Character is in the target and position matches. We're gonna have to want to do something with that. Probably here it's gonna do like guess feedback. Yeah, I'll just put guess feedback here. We're gonna have to like, it's probably gonna have to like pass in like, we're gonna need to pass in some char c, which is the character, the int n, which is the 2. So this is gonna be 2, I think, and then we also need to pass in the int I, the index. Okay, we'll come back to this later. Let's look at our else. So now we have to figure out if it's a 1 or a 0. If it's a 1, that means that the character is in the target and position does not match. So we basically have to go through we have to go through the target word. Oh my god. To go through the target word, and we have to check if it exists. So our current character, we're going to check if it equals anything in the target. If it does, we're going to want to break out of this. But if it does, then that means a1 character in the target is in the target. It's just in the target. Position doesn't match. Okay, because obviously if this position matched, it would have gone up here. So it's probably going to be a guess feedback again. Again, pass in char c into n equals 1 to I index. And then it's going to break out. And then if this for loop doesn't find it, then we're going to do it's a 0. Character is not in the target. Feedback. Pass in char c into n equals 0. Probably no index. I mean, we could pass it in anyways. Okay. So let's see if it breaks out of this loop. Okay, problem here is if it breaks out of this loop, it's still gonna execute this, which we don't want. So I'm gonna need a boolean that says it's like found 1. It's gonna be false here, and then it's gonna become true if I find it. And then we only do this if it's false. Yeah, okay. So you get that. Okay, let's figure out how we want to structure this. So obviously you're passing a character C. Guess feedback, so character C, the integer n, and the index. Character C. Okay, let's pass in the index first. So this is going to be a 2. Now we're going to pass in the character next. So the guess I. And then we want to pass in I, just the index. Okay, so this seems simple enough. Oops. Make sure we have a semicolon. We're going to basically do the same thing for all these, except this is going to be a 1, this is going to be a 0. over here, and then over here, semicolons. Okay. It's our guessing system. It doesn't return anything, don't have to worry about that. Does it for every character. Okay, so now we're gonna need our guess feedback. Just this guess feedback function. So I'm gonna steal it from our previous code. Put it here. Woo! Okay, so it's gonna be, what is this? This is NCI. Okay, so this is gonna be int n char c int I. Okay, no input. We're just gonna readjust the words vector. We're not gonna be looping through these, and we've only got char c and char in already, so we don't need these. Don't need that. This is gonna be active words. Okay. So it should be the same thing. We're just looking at these again. These should all be active words. Indexing is right here, just passes in the index. So it's basically like the for loop that was outside of this. So this for loop right here has been moved to our evaluate guess function. That's basically what we just did. Yeah. So this for loop outside has been moved to our evaluate guess function, and then this inside stuff is still here. It's just appearance to these guess feedback functions. Any changes to these do deletes? I don't think so. We don't want this anymore because we don't care. Do delete should be active words. Okay. We don't care about the. Do we care about the file stream? We can do this. We'll keep this. Probably slow down the program, but it's fine. Okay. Make sure we close it at the end. Simple. Got that. Looks fine to me. Oh, this should be active words. Yep. So this should still work properly, just like it did in the previous program. And we're gonna have to copy over the contains function. So here's the contains function. Contains function needs to check active. Oops. Needs to use active words instead of the words. Oh, anyways, is the word. Oh, never mind. It's just searching the string. So that's what it was for. Okay. So then this should be fine too. And I think that actually is everything down here too. So, evaluate guess, goes to guess feedback. Same thing as before. Checks the contains. Same thing as before. Shouldn't be anything different. Okay, so if we come back up to here, afterwards, clear. Oops, save this. Okay, clear. So just take a look. We can get rid of this now because it should be printing properly. Should output and should counter. The words are clear. Clearing it. We're resetting it. We have our string. We're making a suggestion. We're printing out the suggestion. We're evaluating it to change to readjust the vector. We've got a guess attempt, incrementation, check for no solution, check our output solution. It looks fine. Okay, we need to create a test. Oh, yes. One thing I wanted to do, I'm going to get rid of this old Wordle. One thing I did want to do was I wanted to take this old word bank and I wanted to change it to the actual word bank that Wordle uses, because since Wordle's actual word bank is much smaller, I'd expect us to have a better chance at getting guesses within 6. I feel like a large word bank has a higher risk of getting the wrong guess. So we're just gonna take this and we'll replace it with the actual word bank. And you can see it's only 2,300 words now. Oh, actually, wait. Before I do that, I want to copy this over to create an old words.txt, and we're just gonna copy them over. Save that. Get rid of that. Copy over my new words. Here's my new words. New word bank. Only 2,300 words. So that's set. Let's check if it compiles first. So, where is it? Wordle predictor.cpp. Oh, this is the wrong boolean. Found one. Boom, easy. Can we fix now? Okay, we're back. Not sure why the old input.txt file didn't work there, but I closed everything and I just reopened the file. So this should work now. So let's just double check just recompile it just in case. Wordle predictor. And then let's run it. So you ran it, you can see an output.txt file showed up, and there we have it. Favor and 4 guesses, slate, Mary, radar, favor. Yeah, so it works. So I'm guessing slate for this new word set is the way to go. Here we can just put the beginning, pick a few words, and then let's run the program. Boom. Outputs. Yeah, so it looks like slate is the go-to. Oh, what happened here? Slate, taunt, abort, annex, edit. What is going on here? Huh. Slate, user 3. Oh, okay. So this is, it's not doing a end line. So we need to come back and check over here. Order predictor over here. So it's doing, so this has an end line, and this also has an end line. It's not throwing an error. So it must be printing out the guess, and then it goes to this loop, doesn't come through, and it doesn't come here either. So, and this occurs for Abby, and it doesn't even print Abby afterwards. Huh, interesting. What could possibly cause this? Well, it will cause this if the guess is not the input, and then the active word size becomes 1. Okay, so if guess is the input, and okay, if guess is the input in this, otherwise it's probably the active. We can just try it. I think otherwise it's probably just the active word size is just 1, and then we need to print out our input, and then our guess attempt. So quickly compile this again, run it. 3. Okay, so we also need to increment this. So just do that. Right. Run it again. Check it again. Alright, that actually looks good now. Wonderful. Okay, so there we have it. We have a system that can easily tell us the expected guesses and everything. Let's just check what happens if it's slate, because maybe that's sort of like an edge case. Like what happens if it's the first one, or like the first guess. Let's just run it. Slate 1. Okay, that's fine. So here comes the big moment where we're going to copy paste the entire word bank into the inputs, and we're going to want to see if the output has any guesses that are over 6 and see why that occurs. So we're just going to run it. Might take a little bit, so we'll be back once it's done. Alright, we're back. It took a hot second, but it's done now. You can take a look, and here we have it. All 2,500 words. Now, I can already see that there are a few that took a little bit longer than we want them to. So we're gonna go straight to them. So there's the 7. Boxer, goner, homer. Interesting. What else do we have? Catch, hatch, match, found, hand, mound, pound. Oh, okay. So this is definitely a problem. It probably, like, what happens is all that's left is a word with words that end with O-U-N-D, and then it's just there's so many different combinations of the first letter, or possibilities for the first letter, that we can't guess all of them in time. That's not good. So 7. So there's 12 of these that have a 7. Cased, haste, waste. Oh my. Okay. And then 8s. Ta-da. Patch, batch, catch, hatch, match, whack. Watch. 1, 2, 3, 4, 5, 6. That's 6 by itself. So the first guess would have to be patch, just to get that. Incredible. So there's 3 of these actually. Oh, the ound family. Not sure what happens here. Looks like there's just a lot of paths to take to get to Joker. Oops. And then so the watch family and the wound family. Okay, so that's our system for predicting the number of guesses and the guesses that will be used by our program for each of the words in Wordle. Most of them you can see survive the rule, but we've got 3 8s. Are there any 9s? Nope. Are there any 10s? Nope. 11s? Nope. So we got 3 8s and we got 12 7s. So that's 15 words that we cannot get in 6. So I guess next time we're gonna have to look into changing our algorithm a little bit to try to tackle this issue and try to get everything within 6 so that we can guarantee getting the right answer in 6. Alright, see you next time.